Alright, so couple of warm-up problems for you. Give you probably 2-3 minutes to do those. Just moving these up a little bit so I got some space that I can write. On that class in 4th grade.
No, there's not.
All right. First one. Can I get a sum? Why not?
It's bigger than 1.
It's
negative 1.
It's less than -1, really. Yep. Okay, because we're on that negative side. So my R value here is -10/9, which is approximately -1.1 repeating. Okay, and so that's a no-go because that's outside our range. So that is a no sum exists, or sum does not exist type of problem. Okay. Second one, can I get a sum? Yeah, what's my R value? 1/5. What's my first term? -1. Okay, because I take the starting value and I plug it into my rule, if you will, my function. Okay, so -5 times 1/5 is -1. So the sum, the infinite sum formula is my first term divided by 1 minus R. Okay, well, my first term here is -1. My R value is 1/5. 1 minus 1/5 is 4/5. So we've got -1 over 4/5. Refreshing my memory. How do I multiply, or actually, how do I divide fractions? Reciprocate which one? Top or bottom? Bottom, or the one that comes after the divide sign, and then I multiply. Yep. So this becomes -1 times 5 over 4, which gives me a sum here of -5/4. Okay. Again, the majority of this math can be done without using a calculator in this section. Okay? The calculator will only slow you down. Okay? All right. Today I want to kind of focus in on converting repeating decimals into fractions, because the NTC, the tech, every once in a while will throw this kind of a problem into or on the final. Okay? And it's not that hard if we use infinite geometric sums. Okay? So this, if I take this repeating decimal, 0.5555555, and 5 goes on forever and ever and ever. Okay? If I take that decimal and I break it up by looking for the repeat. So if I look for the repeat numbers, in this case, it's only one number. It's 5. So this is really 0.5 plus 0.05 plus 0.005 plus 0.0005, and so on and so forth. Don't believe me? Watch here. Oops. It goes back over here. So that would be 0.5 plus 0.05 plus 0.005 plus 0.0005. If I add all those together, I get 0.5555. And if I keep going, I just keep adding 5s. Like that. line now is an infinite geometric series. Okay? So in that infinite geometric series, I've got a first term. What is the first term? 0.5, 0.5. What is my R value? In a geometric series, how do I find my R value? Roberto. Hi, buddy.
Good, how are you?
Good. How do I find my R value in a geometric series?
Take one term and divide it by your previous term.
Take any term and divide it by the term right before it, right? Okay. So what is 0.05 divided by 0.5? 0.1. Or 1/10. Right? Does that fall in my range? Where I can find the infinite sum? Yes. Yeah, that falls in my range. That's in between 1 and -1. Okay? So now we can go to our sum formula, which was G sub 1 divided by 1 minus R. Okay? Well, my first term was 0.5. Which R value do you want to use? The decimal or the fraction? Decimal. Okay, that's fine with me. 0.1. Mathematically speaking, put it away, Cal. Honestly, wait a minute. Honestly, you don't need it. You don't need it. You know this stuff. Okay? Alright? We shouldn't have any calculators out right now. We don't need them. Okay? Alright? 1 minus 0.1. 0.9. Love it. Okay? So this becomes 0.5 over 0.9. Now, mathematically speaking, do I like that fraction? Why not?
It's decimal. There's decimals.
There's decimals in it. We can't have decimals in a fraction. Decimals are their own identity, their own individual type thing. Okay? Fractions are fractions. Fractions have whole numbers in them. Okay? So what is the one number that I can multiply a fraction by? I can only multiply a fraction by one number. I can only multiply by one, right? Because if I multiply by something other than one, it changes the value. Okay? So if I can only multiply by 1, does 1 always have to look like 1? Give me another way that 1, or another version of 1. Something else that's equal to 1. 2 over 2. 3 over 3. A box over a box. A triangle over a circle. Is that equal to 1? No, because they're not the same. Top and bottom have to be the same, right? Okay. So if I multiply this fraction by 10 over 10, what do I get? What's 0.5 times 10? 5. What's 0.9 times 10? 9. So we get 5 over 9. Is that a fraction that I like? Yeah. I like it because there's no decimals in it. I like it because it's reduced. I like it because it's pretty. Just like me. Okay? Alright? Now let's go to the calculators. What is 5 divided your calculator? 0.5 repeating, which is what we needed it to be. Yeah. So this 0.5 repeating is a repeating decimal converted into a fraction is 5/9 using geometric sums. Yeah. So let's try this one now. This one's a little different because it's got the 5 out in front, and then there's a repeating decimal. Okay. So I'm going to take that 5 and I'm going to set it aside for right now. Okay. It's still there. Right? I can't lose it because it's part of the problem. But I'm just going to put it on the back burner for right now. I'm going to let it simmer for a little bit. And then this becomes 0. Oops, wrong color. And then this becomes 0.146 plus 0.000146 plus 0.000000146, and so on and so forth. Okay. Now, let's just look at the repeating part. What is my first term?
0.146.
What is my R value? Okay. Shouldn't need a calculator for it. Okay.
But then don't you have to do something with that 5?
But let's wait a minute. Let's talk about R first. How do I know, without going to a calculator, that my R value here is 0.001?
Decimal places it goes over.
Because how many decimal places is it moving over?
Sorry.
Exactly. How many decimal places was it moving over? We're going to translate that into English now.
It moved over. This one's 3 times.
3 times, right? Or how many digits are being repeated? 3, right? Okay. So in the last problem, we had 1 digit repeating, correct? And our R value was 0.1. Here now, we have 3 digits repeating, and our R value is 0.001. If I had 5 digits repeating, what would my R value be? 0.00001. Okay. Your R, the number of digits in your R value, or the number of numbers after the decimal place, is the number of digits that you are repeating. Always. Every time. And twice on Sundays. Okay. Alright, so we got that. Now, let's do our sum of just the purple box part. First term was 0.146. R value, 0.001. Again, shouldn't need a calculator for this next one. Okay. Top is going to be 0.146. Bottom, 1 minus 1,000. 1 minus 0.001. 1 minus minus 0.001. What do we got? Shouldn't need a calculator for this one. Okay, so 0.999, right? Do I like that fraction? No. So what am I going to multiply by?
10.
If I multiply by 10, I get 1.46 over 9.99.
Oh, 1,000.
I'm going to multiply by 1,000. Just 1,000? Over 1,000. Okay, because remember, it's got to be equal to 1. Right? So I'm going to multiply by 1,000 over 1,000, or I'm going to move the decimal point 3 spots to the right on the top and 3 spots to the right on the bottom. Now my question becomes a mathematical logic type question. Do I like the fraction 146 over 999? Don't even... Faster. Do I like that fraction?
No. I don't know. Can you reduce it?
Well, do you know the trick to reduce by 3? Because 3 goes into 9, right?
Yeah.
So 3 is going to go into 999, right? Okay. So do you know the trick to if a number is divisible by 3? Colin, stop using your calculator.
No, I don't.
You don't? Does anybody know if a number is divisible by 3 trick?
Don't you add something up, and if that's divisible by 3?
Then the whole number is divisible by
Yeah,
3?
but I
Do you
don't-
know what you have to add?
Is it the last 2 digits?
Nope.
Is it all of them?
All of the digits, right? So if all of the digits of a number add up to be something that's divisible by 3, then that number is divisible by 3. Okay? So 1 plus 4 plus 6 is 11. Is 11 divisible by 3? No. So 146 is not divisible by 3. Which also means that 146 is not divisible by 9. Because if it's divisible by 9, it's divisible by 3.
I think then you like this fraction.
I love this fraction. Okay? Right? So I'm okay with this fraction. Now, we got to bring back the 5. So we've got 5 plus my sum here. So one way of writing this is right? 5 and 146 over 999. Okay? But it asked us for a fraction. Is that a fraction?
No.
No, that's a mixed up number. Okay? So in fraction form, I'm going to take the number out in front, and I'm going to multiply it by the denominator, and then I'm going to add the numerator. Right? That's how we switch to a mixed up, from a mixed up number into an improper fraction. Okay? Now, math tricks. What's 999 super close to? Really close to 1,000, right? So what's 5 times 1,000?
5,000.
5,000 plus 146. 5,146, right? But then I got to subtract off the 5 that I had because to get it to 1,000. So 5,146 minus 5. 5,141. now is I want you to convert that number into a fraction. All right, so I'm going to set the 10 aside for right now. And then what I'm going to look at is going to be 0.36 plus 0.0036 plus 0.000036, and so on and so forth. Okay? So if I'm looking just at this, setting that 10 aside for right now, that gives me a first term of 0.36, which I saw in everybody's paper. Okay? That gives me an R value of 0.01 because I have two digits repeating. I need 2 decimals in my R. So now I can go to the sum is going to be G sub 1 divided by 1 minus R, which is going to be 0.36 minus 1 minus 0.1. That gives me 0.36 over 0.99, which that gives me 36 over 99. Okay? Is 36 divisible by 3? Yes, because 3 plus 6 is 9. 9 is divisible by 3. Is 36 divisible by 9? Yeah, because I can, you guys ever see this trick? 36. Okay, so it's divisible by 9 4 times. So this is 4 over 11. Now I bring the 10 back into play. (10 plus 4/11 is 10 and 4/11. But that's a mixed up number. I asked for a fraction. Okay? 10 times 11 is 110, plus 4 is 114 over 11. Okay? Reducing your fractions helps out immensely.
So if we wouldn't reduce it,
It'd be wrong.
It'd be wrong.
Yeah, well, like 6/8. I've never accepted 6/8 as a fraction. Yeah. Mm-hmm. Okay. Okay. Always reduce. Bless you. Good. This homework is due on Wednesday. The pink sheet that I gave you is due on Thursday. Okay? So this homework for Wednesday, pink sheet for Thursday. Formative tomorrow, test on Thursday. Okay? So lots of stuff happening this week.